All right, so I'm going to go ahead and get started. So starting off with question 11, and if you are here from AP Calc class, go ahead and just say hi in the chat if you want to, and if you have any questions that you would rather me do first, I can always skip ahead and do those first and then come back and do the rest of them. So I'm going to write in green, so I'm just kind of writing over this file. And the first question asked us to find the derivative f prime. So the first thing that I always do is I just start off by finding my zeros, right? So f prime equals 0 whenever on f we have a horizontal tangent line, right? Remember, this is our f graph. So right here and right here, those are my two zeros. So the first step that I'm going to do is I'm going to look for those two zeros. One is a negative value and one is a positive value. So if I look at choice A, I have a 0 here at 0. That's wrong. Choice B, I have the two right locations. Choice C, again, I have this extra 0. That's wrong. Choice D, I have the two right locations. And choice E, I have no zeros at all. So that one's wrong as well. So I'm between choice B and choice D. And what we're going to kind of do is we're going to look on the graph of f. And we see that f is increasing, which means f prime would be positive in the first section. Then f is decreasing in this next section, right, which means f prime is negative, and then f is increasing again. So I want a graph that basically has two zeros, starts above the axis, goes below the axis, and comes back above the axis, and that's choice B. Right, again, I see 4 of us on. So what I can do is, if you do want to just put any comments in the chat, I can always skip ahead to a later question if you just have a couple questions towards the end, and we can go out of order and then we can come back. So if I see anything in the chat, I'll skip ahead to those questions. Otherwise, I'll just go ahead and keep going in order. So our next one, we did this one in class. We at least started it in class, I should say. And so our first step here is always, as soon as I see tangent line, I want to kind of think x1, y1, and m. Now, they did not give me any of those. They didn't give me x1, they didn't give me y1, they didn't give me m. But they did give me the equation to the tangent line. And so we can use that to find m. So the first thing we're going to do is we're going to rewrite this into y equals mx plus b. And we're going to figure out that the m is -1. So we have an m of -1. And so now I can take my other equation, my curve, and take its derivative, which is y prime equals 2x plus 3. Set that equal to that same -1. And go ahead and solve, and we get x equals -2. Once I have that, I'm going to plug that back into the original. And I did that over here. Y equals -2 squared plus 3 times -2 plus 1. That's 4 minus 6 is -2 plus 1 is -1. And none of those are my answer because we're trying to solve for k. So now that I know x1, y1, and m, what we know is that we know that this x1, y1, and m will always work for both the curve and for the tangent at that spot. So now I can plug in both x and y into here. So that's -2 plus -1 equals to k, which gave us -3 equal to k. All right, next up we have a twice differentiable function. They give us some information about it, and they want us to do a tangent line approximation. So same thing, we're going to start off with x1, y1, and m. And then we're going to put this into y minus y1 equals m times x minus x1. So this is kind of that tangent line. This is not the approximation, it's just the tangent line. And then we're going to plug in 1.9 in for x. Not in for x1, but in for this x here. Right? And so we get y minus 1 equals 4 times 1.9 minus 2. A lot of times this value in here is going to be something like 0.1, -0.1, 0.2. Right? In this case, 1.9 minus 2 gives -0.1. 4 times -0.1, we're just moving the decimal over by 1, -0.4, and then add 1 to both sides. If you have trouble with -0.4 plus 1, just go ahead and read it backwards. Read it as 1 minus 0.4, And that should be really easy. 1 minus 0.4 is 0.6. All right, next up we have another tangent line one. And this one, might have been weird if you just looked at my work. But what's happening here is when we see tangent line, okay, again, we're kind of thinking x1, y1, and m. Now this time they gave me the x1 is 1. They gave us the y1 is 7. But we don't know the m. And they want us, in fact, to find the m because they're asking me to find f prime of 1. Well, f prime of 1 will be our m. Right, that's going to be kind of the same as the m by definition. Right, definition, the derivative is our slope. But what they did instead is they said, hey, this line, and it's a line, also passes through the point -2, -2. You could graph this if you really wanted to, and you could, count. And you could count like up so many, over so many, but this is the tangent line. And so the slope of any line is just y2 minus y1 over x2 minus x1. Now you can go in any order, so I chose these to go first, the 7 and the 1, because they're positive, and it's just easier for me to start with the positive number. 7 minus -2 over 1 minus -2, right? This is just y2 minus y1 over x2 minus x1. You plug it in, and you go ahead and get 3. Okay, I like the question. So going back to 24, Jimena asked, is it fine if I solve for y first and then plug in? Absolutely. Absolutely. That's a really good strategy. So on this one, on 24, we have y minus 1 equals 4 times x minus 2. So the question was, could we solve for y here? So yeah, we could put this into y equals mx plus b. Y minus 1 equals 4x minus 8. Then add the 1. And then we would get y equals, I'm going to kind of put this up here, 4x minus 7. And so then we could do, okay, what would f of 1.9 be? Put that in for the y. Would be approximately 4 times 1.9 minus 7. Now, the only thing with this is you don't get the benefit of, when I plug it in here, and I get that 0.1. I know I just moved the decimal over. That's pretty easy. But 4 times 1.9 shouldn't be that hard. Oops. Let's see. I think my tablet just get disconnected. Give me 1 second while I try to figure out how to get it back. Second screen. Difficulties. All right, so anyways, we had that 4 times 1.9. And so you may just do that off on the side. You might be able to do that in your head. 4 times 2 is 8. And then we need to get rid of, the 4 times 0.1. So you could do that, or you could just, kind of do it the long way. Is 1.9 times 4. We do -4 plus 5 plus 3. And that gives me, I didn't write it out, but that gives me 1 plus 3 of 4. Right, so that's my y1. And for m, we always get m by taking the derivative, 12x squared minus 5. We don't set it equal to. I know sometimes when we haven't done this in a while, we're thinking like, oh, do I set it equal to 0? No. Do I set it equal to -1? No. What we're doing is we're plugging in -1. -1 is an x. We're plugging in -1. Right, you set a derivative to 0 when we want to find the maximums or the minimums. This is a tangent line, so it's a little bit different. Right, so we plug in -1, square it, 1, 12 minus 5 is 7. So now we have our x1, our y1, and our m. We plug this in, y minus 4 equals 7 times x plus 1. I would look for this answer first, but I see that everything's written in y equals mx plus b. So we just go ahead and distribute the 7, add the 4 over, and that would give us y equals 7x plus 11. There is a delay, by the way, so again, feel free to ask questions, or if you want me to do another one first, feel free to ask about that. I might see it a little bit late and just have to come back to it, but that's totally fine. I would love for you guys to ask questions. Okay, next one, the graph of f prime. The derivative of f is shown above. And we're asked on what intervals is f increasing. I actually didn't have any of these on this one for the concave up section just because this is chapter 2. And we didn't learn about concave up yet. But really, anytime we're seeing this graph of f prime, what we want to be thinking about is that if f prime is positive, that means f is increasing. If f prime is negative, that means f is decreasing. Then if f prime goes from positive to negative, if it changes, like it's a 0, then f would be a relative max. And if f prime changes from negative to positive, then that would mean that f is a relative minimum. This is everything for increasing, decreasing. Now, the stuff that we'll review again later is that when f prime, the graph itself, is actually increasing, like the graph is going up of f prime, that's when f was concave up. And when f prime's graph was decreasing, that's when f was concave down. So again, this is not on this notes, but I just wanted to mention that. Right, like this section here, where f prime is literally increasing, that would kind of match up with f being concave up. So just a quick side note. Anyways, this one said on what intervals is f increasing? So that's when f prime is positive, f is increasing. So when we're saying f prime positive, that literally just means any time that the graph is above the x-axis. So where is this graph above the x-axis? It's this entire section. Now, I might first kind of look at these zeros, -2 to 1 and 1 to 3. So I might try to look for something that like this, -2 to 1, union 1 to 3, but I don't see that when I look here. And I've told you guys this, sometimes textbooks combine these, and in this case, they combine them to be from -2 to 3. They also use brackets. I don't really like brackets because I feel like at 3, the graph isn't increasing or decreasing, but they use brackets. That's totally fine here. Our next one is our first calculator question. And so I'm going to go ahead and pop the calculator up in a second. But when we get the first derivative of a function and they give us that first derivative, that's nice for us because we can graph that. So they say, where is the graph of f increasing? So this is the exact same thing, but instead of giving you a graph, we have to do the graph on our calculator. So we're going to graph f prime, and we want to know, since it says f increasing, where is that f prime positive? So I'm going to go ahead and pop open our graph. There we go. So we're going to hit tab, and we are going to be graphing the derivative. So trig, sine, and then x cubed minus x, all in parentheses. And we get something kind of crazy looking like this, which is fine. This looks all over the place, but we want it from 0 to 2. So we're going to go to menu, and then window zoom. And we're going to change our window settings to be from 0 on the x to 2 on the x. And so I want, where is this graph positive? I want this section here. So we're going to go to menu, analyze graph. We're going to pick out our zeros. We want to go to the left of that, then to the right of it, that's 1. Go to menu, analyze graph again. And 0 a second time. Then to the left of this 0, to the right of that 0, and we get 1.69. So from 1 to 1.69 is where a graph was positive, and that was choice B. All right, next up, we have another graph of f prime. And in this case, they're asking us, where does f have a relative maximum? So where does f have a relative maximum? So we just need to remember, we talked about it up above, that relative maximums occur when f prime changes from positive to negative. So above the axis to below the axis, that's at 4. Don't worry that these look slightly off, it's just a bad graph. But basically, -2 is changing from negative to positive. This would be a relative minimum. Then at 1, we're not changing signs. It stays positive. It was positive, it stays positive. So this would be a neither, right? Neither a max nor a min. And here we change from positive above the axis to negative below the axis. So this is our relative maximum at x equals 4. That's the only one. So choice C. Next up, we have a f prime of e, and then we have all these limits. As soon as I see all of these limits, I want to be thinking to the definition of the derivative. So something with the definition of the derivative, and then we want to be thinking if it's f prime of e, that's not the general derivative, but that's the derivative at a specific point. So this is the formula that you kind of need to memorize, right? So f of x is e to the x. So f of a plus h would be plugging in a plus h where we see x. So this is e to the a plus h. Now I don't want a in this case. My a is e. So what we want is, let's change those a's to e's. So it's going to be f of e plus h is going to be e to the power of e plus h. Then f of e, right, because we want f of a, so f of e would be e to the power of anywhere I see an x, I'm going to plug in e. And so this gives me, down here, e, the limit as h approaches 0 of e to the e plus h minus e to the e all over h, which matches with choice E. Good question. The difference between B and E is on B, there's an X right here. Right? It's kind of hard to see. They look really, really similar. But on B, there's an X right there. Whereas on E, there's an E there. So on B, what B was, B would have been the limit as h approaches 0 of f of x plus h minus f of a over h. But that's not correct. It's the limit as f approaches of f of a plus h. So you kind of want to remember on this one is if it's the derivative at a point, there should actually be no x's in your answer. So A is immediately wrong because it has an x in it. D is immediately wrong because it has an x in it. B is immediately wrong because it has an x in it. So I'd have to be between E and C. Now in E, they didn't plug in that e to the e. That e to the e part is missing, right? So that's why C was wrong. But I really like that question because it's actually a really good kind of strategy on this. Is if I'm using this formula, then I shouldn't have any x's in it. That doesn't mean for every definition of the derivative we're not going to have any x's. But for this one where I'm plugging it in at some specific point and using the limit as h approaches 0 formula, there won't be any x's in it. So, if that kind of confuses you, go back up here and just really make sure that you memorize, especially these two formulas, the two with the limit as h approaches 0 formulas. And that should help out. This one will have x's in it because it's not at a point. Whereas the second one will not have any x's in it because it's at a specific certain point. Okay, moving along, we have another graph of f prime. This is a very, very common multiple choice question, is to give you a graph of f prime and ask you to analyze that graph. So the graph of f prime, the derivative of a function is shown above. Which of the following statements is true? So when we have this, we're thinking those same concepts. F prime is positive, f is increasing, f prime is negative, f is decreasing. F going from positive to negative is a relative max. I only included that one because that's the only thing that happens here. It never goes from negative to positive. So I want to be kind of thinking those in my head and then just going through each one of these. So the choice A says f is decreasing from -1 less than or equal to x less than or equal to 1. So this f is decreasing would match with f prime is negative. Okay, well, f prime is negative between 0 and 2. So this is wrong because the interval is wrong. Next, we have f is increasing, right? That's f prime above the axis, positive, for negative 2 to 0. And when I look, yeah, that matches up. Now, I like to just read through C, D, and E just to make sure that they are, in fact, wrong. But my guess is that it's going to be choice B. Then C says f is increasing between 1 and 2. That's wrong. They're literally saying like 1 and 2 because that's where the graph is going up. But that's f prime is still negative, right? When f prime is increasing, that would be concave up. So C, if it had said f is concave up there, it would have been correct. D says f has a local minimum. No, it's a local max because f prime changes from positive to negative. And E says f is not differentiable at negative 1 and positive 1. F is actually differentiable, right? Even though this graph makes a corner at these points, f is differentiable because it exists, right? It was graphed. F prime would be not differentiable. So we can't take the derivative of the derivative, but we already did take the derivative and we already graphed it, right? There are no holes in this graph. So as long as we have no holes in this graph, no jumps, no discontinuities, f was differentiable. Next one specifically warns us that there's no calculator. I did talk about this one in class and kind of get us at least to here, I think, in class, where we're going to take the derivative, which we're already given, and normally, when we see where is f decreasing, normally all we need to do is set it to 0. But because of this fraction, we also need to set it to d and e. So we're going to set it to both 0 and to d and e. And we get x cubed over x minus 2 over x equals 0, right? We're kind of lollipopping this and getting a like denominator. And then we get x cubed minus 2 over x equals 0 in d and e. Anytime we have a fraction and we're setting it to 0 in d and e, we need to turn it into one fraction so we can set the top to 0 for the 0 case and the bottom to 0 for the d and e case. So I add 2 over, I cube root it, and I get x equals the cube root of 2. And here I just have x equals 0. Then we're going to make a number line. I'm going to label this as f prime. And we plug this back in to the derivative, right? So you can either plug it in here, or you can plug it in back here to the original. But we're going to plug it into the derivative. So I plugged in negative 1, right? I plugged in kind of to this guy. So negative 1 cubed is negative 1 minus 2 is a negative over negative 1 is a negative. Negative over a negative gave me positive. And likely, this is just going to switch signs each time, but we can just double check. If I plugged in 1, right, 1 cubed minus 2 is negative over 1 is positive. Negative over positive gave me a negative. And then if I plug in, say, like 10 cubed is 1,000 minus 2 is positive, over 10 is positive, so I get positive. So this would be increasing, decreasing, then increasing. Yes, where is this decreasing? So that's between 0 and cube root of 2, which is choice D. Are you saying, Jimena, because like we only have cube root of 2 and 0, that you wanted to choose D? So we want to still be careful because the answer technically could have been B from negative infinity to 0, or it could have been E from cube root of 2 to infinity. So even though I have those two, it doesn't necessarily have to be the in-between case. Now, this is a little bit of a hint. I know Diego is really, one who really likes to guess and do that kind of stuff. Is most of the time, if I have 2 points, any 2 points, doesn't matter what they are. We'll call it box and triangle. Most of the time, if this is positive, then I get negative and I get positive. So, like the two outer ones, in this case, would be the same. So if there's only ever one interval, it does need to be this middle interval, because there weren't two answers. But there are cases where you might get, box and triangle, and you get positive, positive, negative. And so then the answer could be, from negative infinity to here and from here to here, and they might combine those. So it's safe to always do a number line. It's just a little bit safer to really just double check it and make sure you do that number line. It doesn't take that long to do a number line. And if you do get messed up on your number line and you want to just choose D because you feel like that's a really good guess, go ahead and do that. But I think it's worth it to take the extra 30 seconds to a minute to do that number line. Because you never know if it is going to be one of these ends, right? Like if it was positive, positive, negative in this case, it would have actually been from cube root of 2 to infinity, and the answer would have been E, right? If it would have been positive, positive, negative. This next one, the key to this question is the derivative of g prime of a function is continuous and has exactly 2 zeros. That exactly 2 zeros is a key. Now, what is that talking about? Is that talking about g or g prime? It's talking about g prime. They're saying the derivative g prime is continuous. So g prime is continuous and g prime has 2 zeros. Now, they give us those 2 zeros. So there's a 0 at negative 2, 0 and at positive 2, 0. And they give us the table. They said the domain is all real numbers. And then where is g decreasing? So where is g decreasing? Well, g would be decreasing when g prime is less than 0. And so that would be my negative values that I highlighted. And we want to select the x values that kind of correspond with that. So between negative 2 and positive 2. Now, one note about this is they did need to tell us this exactly 2 zeros. If they didn't tell us that, we would have no way of being able to answer this question because we wouldn't know if the graph went positive, negative, a bunch of times in between, like the decimals in between. But because they told us we had 2 zeros, then we know basically that this graph is essentially increasing until we get to negative 2. And then, so it's increasing, we get to negative 2, it decreases until we get to 2, then it increases again. Because my g primes are positive, then negative, then positive. And I don't have any other zeros for g prime, so I don't have any other critical points. Next up, we have if f is a function such that the limit as x approaches 2 of f of x minus f of 2 over x minus 2. As soon as I see this, it's kind of that like y2 minus y1 over x2 minus x1 in a limit. I immediately want to think, as soon as I see that, that's f prime. Now that's f prime of 2. It's one of my definitions of the derivative. That's equal to 0. And that's key. If I don't see that, I can't get this question right. So that's, going back up to that first page. That is this form, right? It's as x approaches a number of kind of like y2 minus y1 over x2 minus x1, where the first two are f of x's and the last two are f of that number. All right, so once I know this, f prime of 2 equals 0, then I just want something that matches up with this. It could be that we have a critical point there. It could be that we have a possible maximum or minimum. Or they literally could just say the derivative of f at x equals 2 is 0. And that's just the definition of what we just said. We said f prime of 2 is 0. The derivative at x equals 2 is 0. That's what that means. All right, next one. We did this one in class where this was not the definition of the derivative. I'll just explain it one more time briefly. But the reason this is not the definition of the derivative is in order to be the definition of the derivative, we would have had to have the limit as x approaches pi over 4 of sine of x minus sine of pi over 4 over x minus pi over 4. This top would have had to be two separate terms. It's not, it's just one term. So it's not definition of the derivative, it's just actually a normal limit. So I'm going to just take pi over 4, plug it in, anywhere I see an x. And that gives us sine of 0 over 0, sine of 0, 0, 0 over 0, so we do L'Hopital's. Now, for this derivative of the top, it's sine of box. The derivative of sine of box is cosine of box times the derivative of the box. So cosine of x minus pi over 4 times the derivative of x minus pi over 4 is 1. Then in the denominator, the derivative of x is 1, the minus pi over 4 goes away. Then I plug in pi over 4 again. And we get the cosine of 0 over 1. And the cosine of 0 is just 1. So our answer is 1. This next one is really weird. A lot of students mistakenly pick 3. Okay, this is the one that like a lot of students, they think it's 3, but 3 is actually a wrong answer. And the reason they think it's 3 is they look at this and they're like, oh, we have a relative maximum, we have a relative minimum, we have another relative maximum. Those are all 3 critical points. They're like, oh, I'm going to pick 3 because we have 3 zeros. It's not 3 zeros. P prime of x equals to 0. This happens 3 times. Right? But they didn't ask for that. They said, how many times does P of x equal 0? And so what you need to do on this is you need to graph it. So I kind of graphed it up here. I graphed -2 and 4. And I graphed 1 and 1. Imagine I don't have all the blue in there. And then I graphed 5 and 7. And I thought, okay, this is a maximum, so it kind of has to go like this. This is a minimum. I'm going to connect it. This is a maximum. It has to go like this. And I didn't see any zeros, but I'm like, wait, I do have to keep going. And because I have a maximum and no other maximums, it's just going to have to keep going down forever. Because it's a polynomial, right? It's a polynomial. I'm not going to have any asymptotes of any kind. Then on the right side, it's just going to kind of keep going down. And so I have 1, 2 times that polynomial of P of x cross the axis. So the answer is B. I think that was really tricky. It is a little bit of an IBT question, kind of saying, okay, I don't have any zeros from 4 to 1 or from 1 to 7, but there will be a 0 on each side. Next up, I see this limit as h approaches 0. As soon as I see limit as h approaches 0, every single time I see that, my first thought needs to be definition of the derivative. So this is the definition of the derivative. And this is just the general form, right? I don't have anything that I'm plugging in for x. It's just the definition of the derivative for y equals tangent of 3x. It's like tangent of box. The derivative of tangent, we need to memorize as secant squared of the box times the derivative of the box is 3. So they just brought the 3 up to the front, and the answer is 3 secant squared of 3x. Next up, we have another calculator question. So I'm going to go ahead and pull up the calculator in a minute, but we want to read this and make sure that we know what we're asked for and what we should graph or plug in like the solve to 0 or just plug into a derivative or anything like that. So it says, is the derivative given by f prime of x? Oh, if the derivative is given by f prime of x equals this function, then at what value do we have a relative maximum? So we're given f prime already, which is nice. So all we have to do is graph that f prime and check for relative maximum. Where does f prime change from positive to negative? So I'm going to go ahead and graph that. And they didn't give me a window to look at, right? And I really like to have those windows to look at. But if you kind of want to cheat, is pick something a little smaller than negative 0.46 and go like my x minimum from -1, and my x maximum, the biggest x value in here is 3.7, so make it like, say, 4. And that could just make the zoom a little bit nicer for us. So let's do this. So if I have another graph, I'm just going to start off by going Menu, Actions, Delete All. Tab. We got e to the x minus 3x squared. Go ahead and graph that. And I do see the maximums right there, but I'm just going to kind of change my zoom. You can also just go to, if you don't want to mess with the recommendation I had, you can always start off with just standard zoom if they don't give you anywhere to go. And this looks fine as well. So a maximum is where the graph changes from negative, the graph of f prime, right? Because this is f prime, changes from, positive to negative. So it's negative, positive, positive to negatives right there before 1. Don't guess at it, though, because they did give 0.95 and 0.91 as options. Go ahead and go to Analyze Graph 0 and make sure you actually find the exact one, which is 0.91. All right, next up we have a function given by x cubed plus 12x minus 24. And all of my choices are saying increasing, decreasing, something like that. So as soon as I see that, I want to take this derivative, set it equal to 0. So the derivative x cubed plus 12x is 3x squared plus 12. Right, I took the derivative, set it equal to 0. Now I could factor out a 3, and I get 3 times x squared plus 4 equals to 0. This has no solution, right? If I move x squared, basically set x squared plus 4 equal to 0, subtract 4, square root, there's no square root of a negative. Now, when you get no solution, what this means is that there's no critical point. And when there's no critical point, you still do a number line. This can be tricky, but you still do a number line. And what happens is, basically, your answer is going to be that we're always increasing or always decreasing, because there's nowhere that changes. So I could get rid of A, B, and E, because I know my answer is always going to be increasing or always going to be decreasing. Because there's no critical point, I just pick any number in the world and plug it into f prime. I chose 0 because 0 is easy. So when I choose 0, we plug it in here. 0 squared plus 12 is positive. And so my answer is that we're always increasing. So choice C. All right, and then now we get to move on to the free response. So for our free response, the first question says use the data in the table to approximate C prime of 3.5. As soon as we see the word approximate, we now have kind of a few different, we actually have all three of them. So the first thing we can approximate is we can approximate derivative. Okay, so f prime, g prime of some number. And this we do a few different ways. If we're getting them in a table, we do y2 minus y1 over x2 minus x1. And if we're given a graph, we look at the slope. Okay, the second thing we can approximate, which we also did in this packet, is we can approximate the original function, right? F of some number. And they usually tell us to do this with a tangent line. But if they don't tell us a tangent line, that's what we're doing. And now the third thing that we can approximate, which is new, is the integral from a to b of some f of x dx. And we do this with a Riemann sum or a trapezoidal sum. This is not until the last chapter that we just learned, but those are now the three things. When we see the word approximate, we're thinking which one of those. So in this case, they want us to approximate C prime, which is a derivative. So that's going to be the y2 minus y1 over x2 minus x1. Now 3.5 is somewhere here in the middle of 3 and 4. So we're just going to write C of 4 minus C of 3 over 4 minus 3, 12.8 minus 11.2 over 4 minus 3. I get 1.6. Now for my units, it says indicate units. How do I know what units? Well, just kind of look. I divided these, which were in ounces, by these, which were in minutes. So my units are ounces per minute. Okay, and if you don't know abbreviations, like I said in class, just write them out. All right, next, very similar question. Use the data in the table to estimate. Estimate is another word for approximate. W prime of 12. 12 is somewhere in here. So we're going to do W of 15 minus W of 9 over 67.9. Or sorry, over 15 minus 9. So that gives 67.9 minus 61.8 over 15 minus 9. This was a calculator question. So I just typed it into my calculator. And again, for the degrees, the 67 and the 61 were on top. So degrees Fahrenheit goes on top. And per minute. Okay, I know mine kind of got canceled out, but it's per minute, right? Not M, but minute. M is meter. And it says, using correct units, interpret the meaning of your answer in the context of the problem. So this problem, W is given as the temperature of water in a tub at time t. And so W prime will always be the rate of change of basically whatever they gave us. And so my kind of template for us is to say this is the rate of change of, right? This is always the start. This is the rate of change of. Then the temperature of the water in a tub. That's what they gave us. And comma, in whatever units we add up here. And at whatever time that we're. So if you answer it this way, you'll always get the full point. All right, we got a lot of bots in here tonight. Oh. All right. Next up, we have the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time 0, it weighs 20 grams. If B of t is the weight of the bird, here's this derivative. And whereas, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So gaining weight, when I see that word gaining weight, right, that's not the original, but that's the derivative. So basically all they're asking is the derivative bigger at 40 or at 70? And the derivative, we don't plug in t here, we plug in b. So I wrote this as db dt equals b of at b40. I know this is a little bit of a weird notation. If you had just written b prime of 40, that's fine. If you had just written b prime of 70, that's also fine. So I plug in 40 into this derivative, and I got 1/5 times 60, I got 12. I plugged in 70, I got 1/5 times 30, which is 6. So 12 is a bigger number, which means b prime of 40 is bigger than b prime of 70, which would indicate the bird is gaining weight faster when at 40 grams, because that's where the derivative was bigger. So that's kind of what I wrote down here. The bird is gaining weight faster when it weighs 40 grams because b prime of 40 is greater than b prime of 70. You do need to plug them in and show that. You can't just write this without showing the work that we had above. You need to show that work. Next up, at the beginning of 2010, a landfill contained 1,400 tons of waste. The increasing function W models that total amount of solid waste, and planners estimate that W will satisfy the differential equation dw dt equals 1/25 W minus 300 for the next 20 years. W is measured in tons at the start of 2010. Use a tangent line to the graph of W at t equals 0 to approximate the amount of solid waste in the landfill. I remember these questions so much screwed me up when I was in high school. Like, this was actually probably one of the questions that was the hardest for me. I don't know why. It was just really the hardest for me, and I think it was because I was so used to x1, y1, and m, and I had no idea what to make x1. Okay, really, really easy is whenever we're given these context, these rate questions, time will always be your x1. And whatever else they give you will always be the y1. And whenever you see a derivative of that whatever else they gave us, that will be the m. This kind of always works for these FRQ ones. So they said use the tangent line at time 0. That's the first thing I'm going to do, at time 0. Okay. Now for my y1, I don't really see a y1, but I'm going to go back and reread this. And it says, at the beginning of 2010, a landfill contained 1,400 tons. And as I keep reading it, it says, t is measured in years from 2010. So basically, t equals 0 is 2010. So that means that W of 0 is equal to 1,400, and that W of 0, that's going to be my Y1. So 1,400 is my Y1. And that's probably the trickiest part, is that part right there, is picking out that 1,400 goes into the Y1. But here's the nice thing, there aren't really a lot of numbers to choose from. 20 doesn't make sense, it's just kind of telling us the domain. And this is obviously the rate. So that's the M. The only other numbers would be 2010, but that's a time, or 1,400. So it's got to be 1,400. That's really the only choice. Okay, now for the M, we do dw dt, and it's 1/25. Now, W is not 0. A lot of students will pick 0 there. But W is the Y1, right? It's whatever is not time. So that's the 1,400 number. Minus 300, that's 1/25 times 1,100. I did it the long way, and I got 44. So now I have Y minus Y1 equals M times X minus X1. And they say use that tangent line to approximate the amount of waste after 3 months, and they tell you that that means time 1/4. So I'm going to I changed Y to w of 1/4, you could keep writing it as y. It won't matter. So y minus 1400 is approximately 4400 times then for x, we plug in 1/4. 1/4 minus 0 is 1/4. 1/4 times 44 is 11. Right? So y minus 1400 is approximately 11. Add 1400 over, and we get w of 1/4 is approximately 1411 tons. Right? And I think we have, 3 more questions. Awesome. So next up, we have this mosquito question where they give us the rate of change. So before they were giving us the original, this time they're giving us the rate of change of mosquitoes is R of t. So this already is the rate. This is really important to realize this is the rate. A lot of times they'll call it R to help us out. And mosquitoes per day, that unit, also tells me that it's a rate. Then they tell me there are 1,000 mosquitoes on the island. They say, show that the number of mosquitoes is increasing at time 6. So if the number of mosquitoes is increasing, what that means is that f prime is positive. Now, f prime in these questions is the rate. So that means the rate is positive. Well, R is f prime. They already gave me the rate, right? F prime is the same as the rate. So R of t is the rate. So they just, instead of taking the derivative, I already have it. So if we want to show that the number of mosquitoes is increasing, all we have to do is take 6 and plug it into R of t. So we just want R of 6, and if it's a positive number, then the number of mosquitoes is increasing. So this is the line that you really need. If you have that line and you write greater than 0, you get full credit. That's all you had to do here. So on our calculator, right, just to show how that looks really quickly, is we're not taking a derivative. We're just doing 5 radical t. And I like to put times, but you probably don't have to here. Cosine of t over 5. Control equals at time equals 6. And we probably want to hit Control Enter to get a decimal. We get 4.4379. I like to go out to at least 4 decimal spots. And we say that's positive, it's greater than 0, so the time is increasing. The next one is pretty weird looking, and it's at time 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? And when you read that, it sounds really weird. But we already know that the number of mosquitoes is increasing. That's what part A determined. So when they say increasing at an increasing rate, that's the second derivative, right? If it's increasing at an increasing rate, like double increasing, f double prime would be positive for the rate of the rate would be positive. If we were increasing at a decreasing rate, then f double prime would be negative, meaning the rate of the rate would be negative. Well, we already have the first rate, right? R is the first rate. So how would we get the rate of the rate? Well, that's basically the rate. Oops. The rate of the rate means the rate of R, because we have R. So how do I do rate in math? In math, rate means derivative. So what this means is we want to take the derivative of R. Now, we might set it to 0, we might do something like that, but they say at times 6. So we just need to plug in times 6. So all you have to write down is R prime of 6 equals negative 1.9, and then we're going to say it's less than 0. So on our calculator, what I'm going to do is do the derivative. Oops, lost that. Give me 1 second. Let's see. So I'll go over the explanation while my calculator app is loading. So when you plug in the derivative, you're going to get this negative. Say that it's less than 0. Because it's negative, then that means the number of mosquitoes is increasing at a decreasing rate. The decreasing rate part was the second derivative part, the negative part. It's increasing because of part A, but you don't really have to worry about that so much. Just rewrite that part. So it's increasing at a decreasing rate. Why? Because r prime of 6 was less than 0. All right, I don't know why, but my calculator app is really lagging. So I'm just going to write it out. We would have put in dt. Make sure you put dt and not dx. I've put dx before, and I get these wrong. And in that parentheses, we would put 5 radical t cosine of t over 5. You can copy paste that down if you want to. And outside this second parentheses, you put at time equals 6. The at times 6 needs to be outside the parentheses. And if you do that, it'll give you this answer, negative 1.9132. Then last two questions, we have this graph of f prime. You say on what intervals, if any, is f increasing, justify your answer. So f increasing, we need to match up with f prime being positive. So f prime is positive only right there. So just from negative 3 to negative 2. Because f prime of x is greater than 0. All right, and then find an equation for the line tangent to the graph of f at the point 0, 3. So tangent line, we do x1, y1, and m. x1 is 0, given to us. y1 is 3, given to us. The m is f prime of whatever we have. We have 0. So f prime at 0, we're going to look on the graph. F prime at 0 is this y value, negative 2. So then we just write this in, y minus 3 equals negative 2 times x minus 0. And finally, we have our last one. Let f be a function defined on the closed interval from negative 5 to 5 with f of 1 equals to 3. The graph of f prime, the derivative, consists of two semicircles and a line segment. This is probably telling us semicircles because there might be later on one of those integral questions we've been doing. But this one, we just want to find a maximum. So we have maximums where f prime changes from positive to negative. That happens at negative 3 and again at 4. So our explanation, f has a relative maximum at x equals negative 3 and x equals 4, is f prime changes from positive to negative at those values. All right, so I hope this really helped you guys. Let me know if you have any more questions about any of this, or if you need to go over any of how to type stuff into your calculator. And good luck studying.